Hi class, today we're going to look at ways that we can prove that lines are parallel. This section mirrors section 3.2 quite a bit, but in section 3.2 you knew the lines were parallel and you were given different things about the different angles because they were parallel. For this one we're going to have different things about the angles and show why the lines have to be parallel. So we're going to be looking at the converse of a lot of the postulates and theorems from 3.2. So I'm going to go through those pretty quick, and I'll show you how I want you to kind of write those out. Instead of remembering that this is the converse of the corresponding angles postulate, what we can do is we can just write out what it says. So the converse says that if you have corresponding angles and they are congruent, then you know that the lines are parallel. So I just kind of abbreviate this. I'll write, if corresponding angles are congruent, then the lines are parallel. And it'll probably be helpful to you if you throw in a picture for this. So you can draw a couple lines, make them look like they're parallel. But instead of knowing that to begin with, what we would have is we'd have like these angles are congruent, and then we would know the lines are parallel. So it just kind of depends on what you have first and then what your conclusion is going to be. I'd like to take a minute to talk about this parallel postulate. This won't be something we'll really see in proofs. This is one of Euclid's very famous postulates, and they call him like the father of like the geometry we study. We study Euclidean geometry, meaning like geometry on a plane, and he said that we only really need a handful of postulates to prove everything that he needed to in his day. It actually says this is one of his 5 original postulates. And what it says is something that I'm sure you know and we've used in class and you used it in Algebra 1. But what it says is if you're given a line and a point that's not on that line. So we're given, let's say, line M, and we're given point P, a point that's not on that line. It says that there exists exactly one line through this point that's going to be parallel. If that line were just like a little bit off, then eventually it would intersect. So there's only one line through that point parallel to the given line. And that's called the parallel postulate. I threw that in just to give a shout out to Euclid and all the work he did to help us out with geometry here in the future. Okay, these 4 other converses of those theorems, we'll go through these quickly too. The alternate interior angles converse says that if you have alternate interior angles, and I'll go ahead and draw those out. If I have these alternate interior angles like right here and right here, they have to be congruent to make those lines parallel. So if alternate interior angles are congruent, then that makes parallel lines. Same thing for alternate exterior angles. If the alternate exterior angles are congruent, then you have parallel lines. If you want to draw a quick picture of that, I think the pictures would probably be the most helpful thing to you here. So if you have a couple lines and you have the alternate exterior angles congruent, then you would know that these lines are parallel to each other. And then the last, remember those consecutive interior angles would be like here and here. Those won't be congruent. Those would have to be supplementary. So if consecutive interior angles are supplementary, then you would know the lines are parallel. And remember, that's the only one that they're supplementary, so please don't get to where you're thinking, oh, they're just all congruent. That won't always be the case. So these 2 angles, like angle 1 and angle 2, would have to be supplementary. So I'll just write the measure of angle 1 plus the measure of angle 2 is 180. Then you could say that these lines are in fact parallel. The perpendicular transversal converse says that if you have a couple of lines, so if these lines are both perpendicular to this one, then they will be parallel to each other. So I'll write if two lines are perpendicular to the same line, then they are parallel. So we've gone over 5 different ways to show lines are parallel to each other. Let's do some examples of these so you can kind of see how they're going to look when you're doing the homework. The directions for these will say things like which lines, if any, are parallel. So when I'm looking at these, I'm going to look at each pair of angles separately, and I'm going to mark them on the picture to see what they have. So for this first one, I have angle 2 congruent to angle 8. Well, what I'm going to do first is I'm going to locate where the transversal is that both of these are on. The transversal is L, and do you notice that you don't really need like anything in this part of the picture for that? So the possibility of which lines, if any, are parallel would be these two here, A and B. And I need to look at these angles and tell what type of angles they are to make sure that this actually works. These two are alternate interior angles. So what I would write is I would write the lines that are parallel. A is parallel to B, and I guess the directions will also say that they want you to explain. Your explanation will be saying that, you know, because the alternate interior angles are congruent. And you guys have the luxury of being able to write a little smaller on this, but this would be your answer to 1A if you want to just like find a place that you can write that, because we're going to have a bunch of different answers on these. So I'll go ahead and erase this each time. If you're doing this on by yourself, you can either just kind of follow along, or you can put the marks and then erase it also. So for 1B, we have angle, oops, not angle 13, it was angle 3 congruent to angle 11. So for these two angles here, do you see that this part of the picture is not something that's necessary for these angles, because these angles are just on this transversal? So what I'm looking at is I'm looking at which lines, if any, are parallel. And these two are corresponding angles. So because those corresponding angles are congruent, I know that line L is parallel to M, and you can write that the corresponding angles are congruent. For the next one, I'm looking at angles 12 and 14. So for angle 12 and 14, I'm going to find those on my picture. And you probably don't want to be scribbling out half of your problem each time, but you can just use your hand or your finger or whatever to cover up that part. Do you see here that A is parallel to line B? And these are because the alternate exterior angles are congruent. And please include the fact that they're congruent. If you didn't know that, then you wouldn't be able to say any of these lines. And remember, the directions say which lines, if any, are parallel. You know, there is that possibility. For 1D, we have angle 1 and angle 15. And this is actually one of those possibilities. There's no part of the picture that I can cross off because I have two different transversals going here. I know that these look like they're alternate exterior angles, but because they're not on the same transversal, we don't have enough information to know for sure that these lines are parallel. So here you would just write none. And if you want an explanation, you could write they are not on the same transversal. So I think marking things on your picture and then maybe like covering up part will be really beneficial for you, so that you're making sure you're not giving something that would actually not have anything parallel. For this next one, I have angle 8 and angle 13 supplementary. They add up to 180. So I'm going to locate 8 and 13. Well, these are consecutive interior angles on this transversal. So I can say that L is parallel to M. And I'm going to write that the consecutive interior angles are supplementary. And you can just abbreviate that. And then for the last one, I have angle 8 is congruent to angle 6. So angle 8 is congruent to angle 6. I could cover up actually like 2 different parts of this picture, and it wouldn't make any difference. These are vertical angles, and vertical angles are congruent whether or not you have parallel lines. So this would be another one that you would have no parallel lines, there wouldn't be any, and you could just write, you know, because just the vertical angles are congruent. That's not enough information to say that any of these lines have to be parallel. You know, these could be really far off, not parallel, and these angles would still be congruent. In the last little bit of this, we're going to have some algebra work. This work is going to look almost identical to the work in 3.2 that we did, except now it says you need to find the angles so that these lines are parallel. The setup's going to be exactly the same though. These are alternate interior angles, and alternate interior angles have to be congruent for those lines to be parallel. So you could just set 5x plus 7 equal to 7x minus 21 and go through and solve this. So adding 21 and subtracting 5x, I get 28 equal to 2x, or x equals 14. I'm not quite done with this though, because the directions didn't just ask me to solve for x. The directions want me to find the measure of this angle. So angle MRQ is this angle here. So I would plug that in. 5 times 14 is 70, plus 7, that angle would be 77 degrees. And if you wanted to do a quick double check, you could do 7 times 14 and then minus 21 to find that that's also 77. For this last one here, this one they just want me to find y, so I don't need to plug it back in. So that E is parallel to F. Well, because this is a 90-degree angle, these would both have to be perpendicular for these lines to be parallel. So 4y plus 10 would have to equal 90. So that would mean 4y would equal 80, or y would equal 20. And that's it. We will do some practice of proofs in class for this, and we'll call it a section. Have a great day.